Alright, today we've done a lot of symmetry so far, and we've had to just kind of pick points. We didn't necessarily know what the graphs looked like at all. And today we're going to try and fix that a little bit to have a good idea of what these graphs look like. We're going to try and get some fairly good sketches so that we can do it really quickly. And this skill is going to help you as you go on in mathematics as well, whether you choose to go on to calculus or any other class beyond that. It should help you speed things up. So before we started these notes, you should have got a sheet of parent graphs, like y equals x squared, y equals x to the third, the absolute value of x, 1 over x. All of those are fairly important, except probably the one on the bottom left. That's the greatest integer function, and that's a step function. We don't do a whole lot with that one. You can definitely explore that one on your own if you'd like to, but I leave it on there just so that you've seen it before. It does actually make big jumps like that. It does not connect. Okay? Today we're going to take a look at what would happen if I want to kind of transform some of these parent graphs. Where would they end up? What would happen to them? So think about it. These are always going to be where they start. Maybe if you start with y equals x to the fourth, then it should look like that parabola you have on there. Or if it's the absolute value, it should kind of look like that v. Okay? So some of the transformations we're going to do, the very first one we're going to talk about is a reflection. Right? And really, you've done some reflections already with your symmetry, right? Over the x-axis, over the y-axis, over y equals x, y equals negative x. You've done a lot of them. So this one here in general form is basically saying if I started with y equals f of x and I then put y equals negative f of x, it would reflect it over the x-axis is what it's saying. Okay? So in other words, if I started with y equals x squared, which I think we can agree is right there, correct? Then notice right here that I put the negative out in front of it. So what's that really going to do to all the y values? Because notice it's not this. Do you agree that is not the same thing as what I have written, correct? Okay, this is kind of a negative just way out front. So what's going to happen if I actually made an xy table? Okay, if I made it for this first one over here, well, I would get 0, 0, 1, 1, 2, 4. You agree with that? What's going to happen to all my y values now if I try and make a table for that one? All the y values are going to become the negatives, right? If I put 0 in, I still get 0. I put 1 in there, I square it, I get 1, and then make it a negative. So it'd be that and that. So really you can see how all it really does is it takes every single point on this graph and reflects it over the x-axis. So that red one there is the graph of y equals negative x squared. Now, is it okay to go and make an xy table for that one if you want to? Sure. But you're going to find as we make these more complicated, it's going to be really good to be able to find them quickly. So the original or parent graph was the one that is in black, the parabola that opens up. And then the new one is this y equals negative x squared, which is the one that opens down. Okay? So if you ever see a negative kind of out front like that, it just reflects it over the x-axis. And if you think about it, that's really kind of what we learned the other day, that if we have xy, okay, we would get x negative y is your symmetry with respect to the x-axis, correct? And isn't that what we just did? We made the y's negative. Okay, so that's something, it's how you could phrase it the other way. So now this next one doesn't happen as much, but it does happen. Notice how the negative is a little bit different with where it's located in these two. See how this negative is inside the function? That would be more like that one. See how that negative is inside what's being squared or all that stuff? Or in here it's inside the square root. Now some of you right now are saying, but you can't take the square root of a negative, right? That's what you're thinking right now? But what if x actually happens to be negative itself? For example, if x was negative 2, so it'd be a negative negative 2. Can you take the square root of that? Yeah, you can. So do you see how this negative is inside the function, which is way different from that, correct? That one is much more like the first one we did. It's outside that function. Here it's inside. So this one actually reflects it over the y-axis. Takes every point and reflects it over the y. Okay. And again, if you want to look at it the other way, it means we started with xy, and we ended up with negative xy. And that's what you did before anyways. Okay. That one doesn't happen as much. Okay. Just out of curiosity, what if we did try this one? This one is actually that type, correct? So what would happen if I took y equals x squared and reflected it over the y-axis? I would end up with the same function, correct? Wait a minute. If I take negative x and squared, I actually do just get x squared, don't I? So the algebra actually follows that you do just end up with the same thing. Because it is just a reflection over the y-axis. So that would end up over there, that would end up over there. It would just flip right over. Okay? So are there any questions right now about the negatives? Well, how did I choose to make this graph? How did I know that's what the graph looked like? How did I choose that? Prior knowledge or knowledge you got about 5 minutes ago. It's one of your parent graphs. Okay, the square root of x, right? So that's how you know where it starts, and then you just have to move it accordingly. Okay. Questions? All right. So now we're going to translate. So that's a reflection, so now we're going to translate it. Yeah, this one's not as hard, really. Notice again where the plus c is. Is it inside the function or outside the function? Okay, is it in where the x is, or is it out of there?
Out.
It's outside. So this is outside the function. So this is going to translate it that many units basically up if it's plus. So this one will move it down because it would be minus. And if you just take a look at that xy table again, it should be easy enough to say. So if I do just y equals x squared, right? It'd be 1, 1, 2, 4. Well, what if I make an xy table for this one? 0, all of a sudden it becomes, if I put 0 in there, I actually get now 2, and then 1, I actually get 3, 2, I actually get 6. What's happening to every single one of these values? It's just going up 2. So what does the whole graph do? It just moves up 2. So, and here's where you can use your sketches, being, all right, that's where y equals x squared starts. That's my parent graph. So that's up about 2, right? See how everything else, it just moves, the whole thing. Okay. So in looking at your parent graphs, is there one point that they all kind of seem to share, at least for the most part? Kind of the origin, right? So that's probably one of your best points to move. Move the origin. Okay, so I moved this point, just move it up 2, and make your parabola. Okay. So how did I know that that was the parent graph? Well, here's your x squared sitting right there. So how did I know? Well, what's this parent graph then over here on this one? It's x to the third. Is that what x to the third looks like on your parent graph sheet? Yeah. So now what am I going to do? I'm going to take that graph. I could do this whole xy table thing again for you, right? But the whole idea is that we don't do that every time. We just sketch it quick. We know x to the third looks like that. So what should I do to it if I have to graph that one? Just move it down 3. So I hope it's there. There it is. Down 3. Again, what point did I move? That one right there. And down 1, 2, 3. Okay. Everything else remained the same on that graph. Okay. Again, that's if it's outside. Moves it up or down, whatever it says. If it's plus 2, it moves it up 2. If it's minus 2, it moves it down 2. Okay. Everybody good so far? Here's normally where some confusion may begin. That's if I have to move it left or right. Okay. Do you notice where the c has moved now? C is now inside the function, correct? Whenever in math you see something inside parentheses to some power like this, it's always going to be the opposite of what you think. Okay? So right here, you would think it's a plus 2, and it's inside, so you would think that it should move right 2. Okay? But it's actually left 2. Okay? The reason is I would have to move it left 2 to kind of I would have to put negative 2 back in here to get back to where I started. To get back to 0, you see that? I'd have to put negative 2 to get back to 0, 0 on that one. Okay, and if you want to, I can do an XY table if you would prefer. Would that be helpful? No, you're good? Don't do it? All right. Well, you can do it on your own. All right. So what should I do with this one? Again, we want to graph it quick. How did I know that x to the third was the parent graph, though? Obviously, I just told you. But how did I know? Because it was to the third power. So that's how I knew x to the third was the parent graph. So what should I do? Just move it left 2. There it is. Just pick up the whole thing, move it over. Now in this next one, is this inside the function or outside the function for this one? Here's your absolute value. It is inside. So what would outside look like for the absolute value? What would that look like if I actually had one outside? There'd be like x minus 3 like this, and then a like plus 2 out here. You see how that would be outside the function? Outside where it was before, right? But this is inside, so we're going to move it to the right 3. Oh, you can actually see that one. There it is. So you notice everything else is the same. Okay. So do you see how having these, do you see how we could check y-axis, x-axis, origin really quick on this now if we know what these look like, right? Just get a little sketch in there. Oh, okay, it does this, does that, doesn't do this. It's odd, it's even. You know, it speeds things up a lot. Any questions on this one? This is normally the hardest one. Okay? Because these are just shortcuts, so you don't have to do an XY table every time. All right. Ooh, there's no multiply here. Oops. Should be a little dot there. Hopefully there is on yours. So now we're saying if C is greater than 1, and that means there's some value that I'm multiplying by the function. I'm not adding it. I'm not subtracting it. I'm multiplying it. It says it stretches it vertically. Well, I think an XY table actually might help on this one. Let's do an XY table for the original. So 0, what? 0. What's probably another good value to choose? Okay, 1. So it's 1, comma, 1, and let's like do 9. 9, comma, 3. So you agree these are these points here. So 0, 0, 1, 1, 9, 3, something like that, right? You with me on that? So what does this 2 actually do then? Let's do an XY table for that one. Let's put in the same values, 0, 1, and 9. So if you put in 0, you put 0 right in there, and then it's still 0, right? What happens when you put in 1, though? Yeah, you get actually 2, and when you put in 9, you actually get 6, right? So you do agree it's basically twice as tall as it was before? Okay, so 0, 0 is still there. Okay, when you go to 1, though, it's not at 1 anymore. It's way up there at 2. It's twice as high. And instead of being at 3, now it's way up there at 6. So they say it stretches it vertically. So if you could think of like some Play-Doh and you had the graph on there already and you stretched it like this, you could see that's what it would do, right? I don't know, maybe none of you have ever done that with Play-Doh, but okay. I have. Right? Or I think it's in there, or maybe not. I'm lying.
Why does it say C is great?
I could have been, but there you go. Oh, I see it way over there, yeah. I must have moved the graph. But anyways, that's what it would look like, yeah. This only works, the stretching it vertically, if the C value, the number out front, is greater than 1. Because if it equals 1, you get the same graph, right? 1 times something, you get the same graph. And then down here, we're going to talk, what if 0, well, actually, it should say C. What if C is greater than 0 and less than 1? So in other words, a fraction of some kind that's less than 1, right? And is that what I've shown you here? Well, yes. So wait a minute. This one up here made it twice as tall, so this one's probably going to make it twice as short or half as tall, right? Either way, right? So they say shrink it vertical. Well, how do you do that? How does that work? What do you mean push it down? So what would it look like? I put a rock on it and I smushed it, so you're saying like this, maybe? Yeah, that's how it would work. Well, that's not very symmetric, but hopefully yours looks better than mine, hopefully. But I'm not even going to try and find that one because obviously I moved the graphs or something. So I can see that other one now, but can you see it? Is it? Is it right in the right spot? Oh, there it is. There it is. Which one? That's just the arrows, yeah. On that one, why it looks taller? Yeah, making the base wider, because if I go over here at 1, I'm not going to go all the way up to 1 anymore. If I go to 1, I'm only going to get up to a half. And if I go to 9, I'm not going to get all the way to 3 anymore. Okay, or even if I'm doing any of these other ones. Like if I go to any of them, I'm not going to get as tall as I did before. I'm only going to get halfway there. So those are all great questions. I believe there's another great question at this point.
How does that work?
Well, not why. I mean, I showed you with the ordered pairs as to why that works. It just manipulates the y value. Okay. The reason it really matters is so that we can do other problems faster, so that we don't have to do the XY table every time. That's why we do this. Well, I don't know. It might. So what's missing here? It only did C greater than 0 and less than 1, and then C greater than 1. We talked about C exactly 1. It'd be the same thing. What other C values are we not talking about? Negatives. How come? Why don't we talk about the negatives? We've already done the negatives. They were the reflections. Yeah. All right. Let's try some more here. All right. Graph the following using the transformations. So what's the parent graph for number 1? X to the third. So it kind of looks like a little kind of snake-looking thing, right? Like that. Okay. So now we got to figure out where do I got to put that. Now normally, if it was just x to the third, it would go through 0, 0, right? Is this one going to go through 0, 0? How has it been moved? The minus 1 is outside the function, so it's going to move it down 1. So we know it's not 0, 0, but now 0, negative 1, and then you just kind of make your little sketch in there. Okay. Okay, what's the parent graph on number 2? X to the third again. See, it's to the third, so it's again this little snake-looking thing. But what's that minus 1 do? Does it do the exact same thing it did at number 1? No, it moves it to the right one. Very good. So not 0, 0, but because it's inside that function, so it's going to be the opposite of what you think. Uh-oh. Number 3's got 2 things happening here. What's the parent graph? Still the x to the third. So what happens to this x to the third? Actually, 2 things happen. Right 1 and up 3, right? Right 1, because it's only inside. Yeah, when it's outside, it's up or down, whatever it looks like. It's only when it's inside do you do the opposite. So negative 1, actually, you would move it right 1, and then up 3. So it'd be 1, comma 3, so right about there, right? 1, comma 3, and then you just kind of sketch your snake-looking thing in there. Okay. Again, these are sketches. I just want us to be able to see what they're looking like. Okay. So now looking at these, would you be able to test their symmetry quite easily now? Symmetry to the x-axis, the y-axis, origin. Yeah, you can do it quite quickly now. All right, we got a few more. Uh-oh, what's the parent graph? Well, apparently I have these in there already. That's a bummer. All right. It is a v, okay, the absolute value. And that plus 1, is it inside or outside? It's inside. So this is going to be right or left. And it's going to be the opposite of what you think. It is going to be left. Very good. Okay. Okay, so number 5 has a positive 2. So that means it moves it up 2. Is that what it does? Moves it up 2? Left 2? Right 2? What do you mean bigger 2? Vertically bigger, taller, stretch it vertically. It makes it go vertically faster. How about that? Some say skinnier. Okay, you need to make sure that you know that whatever word you're using is correct. In other words, I just look at it as the y value. Whoa, that's terrible. Well, anyway, the y value being twice what it was before when it started, as just the v. Okay? That goes up faster. Well, not mine, but hopefully yours looks like a v. Mine was not very well done. Okay, a bunch of things happening on 6. Can anybody tell me just anything that's going to happen on 6? It's going to go down 3, I agree. It is going to be a V, not what I was looking for, but yeah. A wider V because it's, not because it's a negative, because it's a half, 0.5. What's the negative do? Upside down, okay, reflects it over the x-axis. Very good. Okay, yeah, you can see it, but that's fine. Okay, so the negative reflects it over the x-axis, right? That's the first thing we did. The 0.5 is the last thing we did. Like smushes it, I think, or puts a rock on it, I think is what one of you said. Okay. The negative 3 out here moves the entire thing down 3. I'll be honest, what I normally do first is I reflect it. Okay, so basically after I reflected it, the V would have been looking something like that, correct? Then I moved it down the 3, so then it would be over here like this, and then you just kind of smush it so then it ends up looking something like that, or like that. Yeah, they're not very good, are they? I should probably take them off there so you can see them now. New software. Okay. Any questions? Or would you like me to make up another one and you try it? You're good? It is. But you will get much better. The thing what somebody said is it's hard to remember it all at once, and it is. And you're going to get better at it. We're going to take several days worth of assignments on this so that you get really good at it. Yes.
Like this.
They will not be add-ons. They will be different. Yep. Any other questions? Okay.